Okay, so this is kind of what we talked about yesterday. It says the figure shows the graph of the polar function for cosine of 2 theta in the polar coordinate system between 0 and 2 pi. And then it says it has points A, B, C, and D. If the domain of F is restricted to just 0 and pi over 2, the portion of the given graph remains consistent. That remains consists of two pieces. One of those pieces is the portion of the graph in quadrant 1 from C to E. Which of the following describes the other remaining piece? So we're just looking at from 0 to pi over 2. Okay, from 0 to pi over 2. So what I like to do, right, is I really like to go to my chart, all right, F of theta, which is 4 cosine 2 theta. And we're just going to play with it a little bit, okay? So it wants to know which parts are we talking about. Is it in quadrant 2 from E to B? Is it from quadrant 2 from E to A? Quadrant 3, E to D? Or, E to A, or quadrant 3, E to D, okay? So it already told me for 0 and pi over 2. So what I really need to check are those values in the middle, okay? See if we can figure out which piece we're talking about based on the angle and the radius. So between 0 and pi over 2, we have pi over 6, pi over 4, and pi over 3, right? And so we're just going to evaluate that function for what we have and just think about where that point would be. We're not going to know that radius exactly or that, we're not going to, yeah, okay? But we can know which direction to go, right? We can know to go positive or go backwards, and that's what it's for, okay? So they tell me that, all right, so let's do 0. All right, so 4 times the cosine of 0 would be 4. All right, so 0, 4. So that's point C, and I like to label it, all right, so I know what it's talking about, okay? And then I'm going to go ahead and do pi over 2 because they gave me that one as well. And so if I do 4 times the cosine of 2 times pi over 2, that would just be the cosine at where? At pi, okay? And what's the cosine at pi? -1, so it would give me a -4, okay? So if I go to pi over 2, all right, and then, which would be up and down, but I want to go -4, I'd land down here at D, right? Okay, so I kind of know which pieces we're talking about. So now we're just going to try to fill in the other values to figure out where I would go, okay? All right, so let's do pi over 6. So if I do 4 times the cosine of 2 times pi over 6, that would just be 4 times the cosine at pi over 3, okay? And what is the cosine at pi over 3? It's 1/2, so 4 times 1/2 would just be what? 2, okay? So if we go to the pi over 6 line, so this is pi over 4, this would be over 6, this one's going to be my over 3, so just as a reference, okay? When I go to over 6, I would go out 1, 2, so that's that piece right there, okay? So it tells me that part of it is from C to E. I'm assuming E is the middle. Yeah, okay, so E's our middle. All right, so that's the piece it's already talked to me about. Okay, so let's do some of the others. So then we want 4 cosine of 2 times pi over 4. Okay, well, that would just be 4 times the cosine at pi over 2. And what's the cosine at pi over 2? It's 0. So 4 times 0 would be 0. So that's going to land me at point E. Okay, so if I go up here to pi over 4, and then I go nowhere out. So there's that point. Now let's do pi over 3. This is going to be the one that tells me. Okay, so 4 times the cosine at 2 times pi over 3. Okay, now think about your unit circle. 2 pi over 3 is going to be in that second quadrant, all right? For 2 pi over 3, my cosine is going to be negative, and it's going to be a negative 1/2, okay? So I'm going to have 4 times a negative 1/2, which is negative 2. So if I go over here to pi over 3, and then I want to go negative 2, I'm going to land down here, okay? So this point, which quadrant is it in? It's in the third quadrant, so it can't be A or B, all right? And is it from E to A or E to D? E to D, okay? So you literally just have to fill in the rest of the points, all right? And graph on that crazy circle, all right? That's the best way to do those, okay? Usually they're going to give you a pretty small domain to look at. Usually it's just 1/4 of the unit circle so that you can easily plug those points in to figure it out, okay? That problem's going to take longer than some of our other problems where it would just say maybe match the graph or something like that, okay? So those are just going to take a little bit longer because you're going to have to plug and chug it out, all right? Don't panic, right? These are not heavily weighted on the exam, so they'll be there though, but they won't be in free response, which is good news, okay? And I will, once we finish this, I'll give you your practice test back so you can see it. Okay, so things we're going to talk about today, all right? Characteristics of the graph of a polar function. We're going to talk about how we find a rate of change, how we find extrema, just all kinds of good stuff, all right? Good news is it's not super lengthy, all right, what we have to do with this last little bit of it, and it will be in the multiple choice, which is nice, okay? All right, so let's talk about how things change on the polar system, okay? So I want you to look at 2 different things. There's 2, or actually 4 situations, but 2 that go together, okay? So if our function, all right, is positive and increasing or negative and decreasing, what are those 2 things, those 2 words that in each sentence, what would you say about them? Yeah, they're kind of synonym. They're synonymous, right? If I'm positive and increasing, or if I'm negative and decreasing. So I'm doing the same thing, okay? If I'm doing the same thing, all right? So not that, okay? So these are kind of synonymous as we're doing the same thing, right? So I'm positive and I'm increasing, or I'm negative and I'm decreasing. Then the distance between the graph and the origin increases. Okay, so if we're kind of using the same descriptors, right, then that distance between our graph and the origin is going to increase. If we look at the next 2 thoughts, we talk about being positive and decreasing, or negative and increasing. I would say those are opposites of each other. They're opposite descriptors. To be positive, we wouldn't think we would decrease, okay? So if we have opposites, the distance between the graph and the origin is decreasing. Okay. So if we can use the same descriptor, the distance is increasing. If we use opposite descriptors, the distance is decreasing. I like to think of that as working together or working against each other. So if I'm positive and increasing, I'm working together. If I'm negative and decreasing, I'm working together. All right? However, if I'm positive and decreasing, I'm working against each other. So that makes it slow down or decrease. Right? Well, now how in the devil do we figure out where those things are happening? Okay, how can we tell when it's positive and increasing or positive and decreasing? All right, what we're going to do is we're going to take that polar equation and we're going to graph it on a rectangular coordinate system. Okay, because I know what that graph looks like for sure on a rectangular coordinate system. All right, that's a sine graph that we've done something with. Okay, we're going to graph it from to 2 pi, because that would be one complete revolution around the pole. Okay, so let's take a look. They graphed it for me. All right, so 1 plus 2 sine x. They graphed it for me. It's my sine function, my roller coaster. What did I change about it? What does this 1 out the end do? Goes up 1, which changed my midline. All right. And then what did that 2 do? That changed my amplitude. Okay. So instead of going up and down 1, I went up and down 2. All right. So there's my picture. So let's look at this picture and see if we can figure out where this picture is positive. So I have positive y values. Let's do that first. Let's do positive first. Okay. So it's positive anywhere it is above the x-axis. Okay, so there are my positive intervals. And then it's going to be negative under the axis. Okay, so I've got positive and I've got negative. Right? Of those positive pieces, let's describe where the graph increases. Okay, so I'm going to increase until I get to pi over 2. And then I'm going to increase again over here at the end. Okay, so those are my positive and increasing intervals. All right, so let's write those. Okay, it comes from the x-axis, so positive and increasing, we would do 0 to pi over 2. And then looks like 11 pi over 6 to 2 pi. Okay, you can use brackets or parentheses, doesn't matter. Okay, let's talk about where it's positive and decreasing. So where is it green and going down? Right, so green and going down would be from pi over 2 to 7 pi over 6. All right, does that make sense? Okay, all right, let's do the next description, negative and increasing. So we're looking at just the red piece, but I want to see where that red piece increases. So it would start here and stop there. So be blue. That would be 3 pi over 4 to 11 pi over 6. And then negative and decreasing 7 pi over 6 to 3 pi over 4. Right. So let's kind of consolidate all of that information into a chart over here. Okay, into a chart. So we've got all these things, positive and increasing, positive and decreasing, negative increasing, negative decreasing. Right. And so it gives me points. So it graphs that picture for us again so we can see it. All right. That's our Limachon. I couldn't get the word out. All right. Our Limachon. It's got a loop in it. All right. So it's the same one. You know, my husband does not want another animal, but he sends me more screenshots of rescue animals than any human on the planet. I'm like, he's like, we can't get another dog. I'm like, okay. Yet he continues to send me puppies. And
Tinder dog?
Yes. They've backed off a little bit. They must have had some pushback from that. I don't know why, but I thought it was great. I'm going to get an adult dog the next time because I am over potty training animals. So, anyway. I want all the pities in the world. That's what I want. I love a pity now that I've had one. Please stop. Okay. He knows it makes me want another one. We got Maverick because Becca was going to college and I was having a crisis. Okay. All right. I needed something else to mother because she wasn't going to be there. All right. So let's take a look at what we just did. We're going to fill in this chart based on what we just did with that graph that we did in the rectangular plane. Okay. So from 0 to pi over 2, we said it was positive and increasing. From pi over 2 to 7 pi over 6, we said it was positive and decreasing. I'm just reading my chart here. From 7 pi over 6 to 3 pi over 2, it was negative and decreasing. From 3 pi over 2 to 11 pi over 6, it was negative and increasing. And then from 11 pi over 6 to 2 pi, it was positive and increasing. Okay, so I just put those descriptors into a chart. All right. Now let's use what we know about the origin. If I have the same descriptor, okay, the distance is increasing. If I have opposite descriptors, then the distance is decreasing. And that's what it's going to ask me, okay? So we can use this chart to help us answer that question, what's happening to the distance from the origin? So positive and increasing, that would be the same descriptor. We would say the distance is increasing, okay? Positive, decreasing, those are opposite descriptors, so the distance would be decreasing from the origin. All right. Negative, decreasing, same descriptors, it would be increasing. Negative and increasing, those would be opposites, so the distance is decreasing. Positive, increasing, same descriptors, the distance is increasing. And so that's how that's going to work. Okay, so your AP exam, your pro tip, all right, graph it on the rectangular coordinate system. Okay, sketch your graph on the rectangular coordinate system. Okay, and then look at your behavior. And the nice thing is it's typically gonna give me some specific ranges to look at, so I don't have to look at the whole graph. Okay, we'll be able to look at specific ranges and see, okay, are the things doing the same? Are they positive and increasing, negative, decreasing? Like we're gonna be able to look and see. All right, so that's your pro tip on how to do those problems. If they ask you about the distance from the origin, sketch the graph on the rectangular coordinate system, look at your descriptors. There's a lot you can do with polar coordinates, and if you go on to do all the calculuses, you get to polar calculus and Calc 3. So you won't see polars again until Calc 3. You also do what are called hyperbolic functions. Those are in 3 dimension. Good stuff. Calc 3 was my favorite. Calc 2 was my least favorite because it's all integration. If you're going to be an engineer, there's like 4 more on top of what everybody else takes. Just kidding. 2 more. Okay. But once you get a certain point, they give you programs to do it for you, so you don't have to do all the math. But you do have to know how to program it. So, okay. So let's look at this example. All right. So it says consider the graph of this polar function, r equals f of theta, where f of theta is 2 minus 4 cosine. Okay, 2 minus 4 cosine on the polar coordinate system from 0 to 2 pi, which of the following statements is true about the distance between the point with polar coordinates and the origin. Okay, so this is where we want to look at the descriptors and graph it on the rectangular coordinate system. Okay, so let's talk about what would happen to this cosine function. Right, let's talk about what would happen with this cosine function. What's the 2 at the end going to do? It's going to move it up 2. It's going to change my midline. So I know I'm going to go up 2, and that's kind of like my 0 all the way across where we'll graph from. Okay. What's the negative 4 going to do? It's going to change my amplitude, and it's going to flip it. okay? So it's going to take that cosine function and it's going to flip it. Now, remember, when we graph cosine, these values are still the same. We're just going out here to 2 pi. We'd have pi over 2 and 3 pi over 2, okay? So let's talk about what cosine typically looks like. Is it your roller coaster or your bird? It's your bird. And your bird typically looks like this, right? Flying crane. But we're going to flip it so he's going to look more like a mountain, all right, who's happy to be there, okay? So at 0 from my midline, we'd go down 1, 2, 3, 4, okay? At pi, we go up 1, 2, 3, 4. At 2 pi, we'd be back down here, and then we'd cross over at 0 in those other places. Okay? Now, remember, when it asks you about this in terms of positive and negative, it's referring to the original x-axis. Okay? Because it's real easy to think about the midline, but we got to think about the original x-axis. Okay? All right, so let's look at what it's talking about here. All right. So positive and increasing, negative and increasing, positive and decreasing, negative and decreasing. All right. So I know I'm positive in all of these places. Okay, so I'm going to start there at my 2 positive statements. I'm going to increase from whatever this value is to pi. So I would be positive and increasing from some value to pi. All right. So is that what it says about positive and increasing? Does it meet the qualifications? It'd have to stop at pi. So this one starts at pi, so that's not it. Okay. All right. Now let's look at positive and decreasing. So that would be the opposite side. So that's going to start at pi and stop somewhere else. Okay, so is there one where it starts at pi and stops somewhere else? Yes, that's my answer. Okay, just walk through them. Okay. All right, and the statement is that it's decreasing. That's true because I'm using 2 different descriptors, positive and decreasing. Okay. See if you can do the next one. This time it gives you the picture and it asks you to find a certain spot. All right, so let's look at this one. So we've got the graph of f of x equals 3 sine of 2x. It models, that's the rectangular coordinates, the rectangular system, and then our polar equation, 3 sine 2 theta. Okay, they graphed it between 0 and 3 pi over 2. And it asked me, where is the distance between the coordinates and the origin decreasing? All right, so let's think about what that would have to mean. I either have to be positive and decreasing, or negative and increasing, okay? So in order for the distance to be decreasing, it's got to be one of those 2 things, okay? So let's look for positive and decreasing, all right? That's going to go from pi over 4 to pi over 2 and 5 pi over 4 to 3 pi over 2. Were those any of our options? Nope, so positive and decreasing ain't it. All right, so let's look for negative and increasing. So 3 pi over 4 to pi is the only one, and there's that bad boy answer. Okay, so just remember, you got it. In order for distance to decrease, you have to have opposite descriptors. Okay. What questions you got about that? All right, 2 more things we're going to talk about, and we're going to be done with this polar mess. Okay. And it's not that it's terribly difficult. It just looks confusing because there's 9 billion words and symbols in there. Y'all feel me on that? Yes. Okay. All right. So where do we find extrema? Where do we find maxes and mins in polar functions? Well, here's the thing. We're going to still graph it in rectangular coordinates. It's the easiest way to look at it. All right. But then here's where we know. All right. It's where our function changes from increasing to decreasing. All right, that's going to give me a max. If we think about that, I'm increasing, then I'm decreasing. I'm going to get a max up there at the top. Okay. Or where it changes from decreasing to increasing. It's going to give me a minimum. So decrease and increase, I would get that valley point. Now, what makes these challenging is graphing them correctly on the rectangular coordinate plane, all right, with all of our transformations and stuff that could be there. So let's take a look at the graph we want to do. 1 minus 2 sine 2 theta. So let's think about what all those transformations are going to mean. What's the 1 going to do? It's going to change that midline. It's going to move it up 1. What's the negative 2 inside going to change? Amplitude, and it's going to flip it. What's the 2 inside going to change? The period. Okay. Period of sine is typically 2 pi, but I'm going to divide it by what's sitting there, which is 2. So now I got to get a full roller coaster between 0 and pi. Okay. It's probably not a coincidence that they told me that was the domain we were going to use. Okay. They told me that's the domain I want you to graph it on. So let's see if we can get a picture first, and then we will talk about all the other things. Okay. So let's do a little graphing. All right. First of all, let's shift it up 1. Okay. And that's going to change my midline. I'm still going to go from 0 to pi. All right. Halfway between 0 and pi would be what? Pi over 2. What would be halfway between those values? Pi over 4 and 3 pi over 4. Okay, so just to give you some reference, we need 4 points to graph our picture. All right. Sine starts at 0, ends at 0, and a 0 in the middle, which is nice. So I got a 0, a 0, and a 0. All right. Typically, we would go up 1, then down 1 in those other spots. But this time, because I have negative 2, what are we going to do in that first pi over 4? Go down 2. So 1, 2. And then in that second pi over 4 from the midline, we'd go up 2. Right? So there's my picture. Okay, there's my picture. All right, so let's see what it says. That I have a minimum, between, I was apparently scared about that. It was very scary. Pi over 3 to 2 pi over 3. Is what it is. Okay. All right, here we go. All right, so let's look at what we're doing. Oh, geez Louise. Okay. All right. So when we're doing this in terms of our extrema, we're talking about the distance. Let me clarify this. Distance from the origin. Bless it. Okay. So we've got to think about those descriptors, positive and increasing, positive and decreasing. Okay. Don't y'all hate it when your voice betrays you like that? Like, it's terrible. Anyway, the worst time that can happen is if you're singing, by the way. That's terrible. And all of a sudden you just get like, oh, I'm so sad. Okay. All right. So let's just kind of split it into pieces and talk about what's happening. So from where I started till I get to this first 0, I am positive and decreasing. So would the distance increase or decrease? Decrease. Okay, because they're opposites. Okay, I'm positive, I'm above the axis, but I'm going down.
What is it increasing? Positive and decreasing?
I said positive and decrease. So the whole thing, the distance is decreasing. Okay, let's look at the next piece. This time we're negative and we're still going down. Okay, so if I'm negative and going down, my distance is doing what? It's increasing because they're doing the same thing. All right, here we go. I am still negative, but I'm increasing. So distance is decreasing. Okay. On the next one, I am positive and I'm increasing. So my distance is increasing. Right? I'm positive, but I'm decreasing. So my distance is decreasing. Okay. So I'm just flip-flopping it. Right? Okay, so we're trying to figure out where we have maxes and mins. The first thing it says is that I have a minimum between pi over 3 and 2 pi over 3, okay? So a minimum would be I changed from decreasing to increasing between pi over 3 and 2 pi over 3. Well, let's see if that happens, okay? So I would change from decreasing to increasing. Okay. So let's see, decreasing to increasing. Okay, the intervals are wrong, right? Because this is going to happen at 3 pi over 4, so it can't be the first one. Okay. Minimum between 2 pi over 3, all right, which would be right here somewhere, and pi. Okay, I changed from increasing to decreasing, so would that be a minimum? No. Okay. Between pi over 3 and 2 pi over 3, I have a maximum. So let's see, pi over 3 and 2 pi over 3. I do not change. I stayed all increasing. Luck of the draw, it must be D, but let's make sure. Okay, from 2 pi over 3, so this first black line, 2 pi over here at the end, I changed from increasing to decreasing. That would give me a maximum. Okay, so you're just going to have to look and think about the values. Okay, look at that rectangular coordinate system. Okay. Alrighty. Last thing we have to do. All right, we've done average rate of change with every type of function we've talked about. Okay, we do it with polar functions as well. Okay. Average rate of change. Every time we've talked about average rate of change, we refer to it as slope. That is no different here. Okay, it is no different here. We're going to do f of the second theta minus f of the first theta over the second theta minus the first theta. Okay, it is still slope. Change in y over change in x, okay, or change in your dependent variable over your independent variable, all right? It is the average rate at which the radius is changing per radian. That's a fun description, okay? So it's the average rate at which the radius is changing per radian. Right. That sounds terrible, all right? It's not that bad. Just a little bit of arithmetic, okay? A little bit of arithmetic. Okay. So let's talk about this one. It says to consider the graph of the polar function r equals f of theta, where f of theta is 3 minus 3 cosine theta in the polar coordinate system. What is the average rate of change over the interval from pi over 2 to pi? Okay, here's what we want to calculate. F at pi minus f at pi over 2 over pi minus pi over 2. Okay, so that's the arithmetic we're going to do. Right? It is slope. Change in y over change in x, like we're used to seeing it. Okay? Now, if we go through and we fill this in, we're going to plug pi into this equation that's above it. Okay? So if we do that, if I just fill it in, I'm going to get 3 minus 3 cosine at pi minus 3 minus 3 cosine at pi over 2. Any ideas what pi minus pi over 2 is? What's 1 minus 1/2? 1/2 is the same thing. It's 1/2 pi over. Okay, so it's pi over 2. All right, that's the same thing as 1 minus 1/2, so pi over 2. All right. Let's simplify, just a little bit of arithmetic here. What is the cosine at pi? Okay, it's -1. So 3 minus 3 times -1 minus 3 minus 3 times, what's the cosine at pi over 2? 0. And we're going to divide it by pi over 2. All right, so again, just a little bit of nasty arithmetic. All right, 3 plus 3 would give me 6. 3 minus 0 would give me 3, so 6 minus 3 over pi over 2. 3 over pi over 2. If I simplified that, what would I do? Keep, change, flip. We're just dividing two fractions. All right, 3 times 2 over pi, or 6 over pi is my average rate of change. Okay. So question about that. Okay, just our slope. All right, let's look at some ways they can ask questions about average rate of change that aren't just find the average rate of change. Okay, because, you know, they couldn't be that kind. They had to make it complicated, right? It's AP. All right, so it says the figure shows the polar function, 3 sine 2 theta. On which of the intervals is the average rate of change equal to 0? Okay, let's think about what needs to happen. If my average rate of change has to equal 0, okay, which would mean f of b minus f of a over b minus a. What part would have to be 0 for that whole thing to be 0? Just the numerator, okay? Just the numerator would have to equal 0, okay? Because 0 divided by any kind of number is still 0, okay? So the only part of this that I have to check, all right, is the top, f of b minus f of a. And that's what we're going to do, all right? We're going to plug them in and check it, okay? Because it has to equal 0. So I got pi over 4 and 3 pi over 4. Looks like I'm doing all the over 4s, which is nice, okay? So at pi over 4, I'm just going to write my cosines, or sines, because that's what I'm using. Or, oh, I don't even have to, because it's, life is good. Okay, so let's do the first one. So I'm going to do 3 sine of 2 times pi over 4 minus 3 sine of 2 times 3 pi over 4. Okay, so that's just going to be 3 sine of pi over 2 minus 3 sine of 3 pi over 2. Okay, well, what's the sine at pi over 2? one, minus the sign at 3 pi over 2. Okay, so that's 3 minus a negative 3 would actually be, all right, it'd be a 6. Okay, give me a 6. Because that'd be a plus 3, and negative times a negative would be me a positive, right? So it can't be the first one. All right, let's try again. Okay, if I try the second one, all right, that's going to be 3 sine. If I plug 3 pi over 4 in there times 2, that would just be 3 pi over 2. Okay, minus 3 sine. If I plug 5 pi over 4 in there, that's going to give me 5 pi over 2. Right, so again, we just got to think about where we're located. The bottom one's going to be a negative 1. Where's 5 pi over 2 going to land? Yep, it's going to land up there at pi over 2. So 3 times negative 1 minus 3 times the positive 1, that's going to give me a negative 6. That don't work either. Okay. Then let's try that next one. Okay. So 3 sine at, this is going to be 3 pi over 2 minus 3 sine at 7 pi over 2. Okay. So sine at 3 pi over 2 is going to be negative 1. Sine at 7 pi over 2 is going to land back at 3 pi over 2. All right, which is going to be 3 times negative 1. So that's going to give me a negative 3 plus 3. There she is, which is a 0. So you just got to kind of plug and chug on those and get your coordinates right. All right, got to get your sine and cosine right, or we're going to have an issue on that one. Okay. Here we go. Last one, and I like this one. It says, in the polar coordinate system, the graph of a function is shown. It's from 0 to 2 pi. On this interval theta, the graph has no holes. It passes through each point exactly once. As theta increases, the graph passes through the points A, B, C, and D in that order. On which of the following intervals is the average rate of change of R with respect to theta the least? Okay, average rate of change, the least. In order for it to be the least, okay, it has to be where my rate of change is negative and R is decreasing. Okay, so where our rate of change, negative, and the radius decreases, or where the rate of change is positive and the radius increases. Okay, so that's what we got to think about in terms of what we're looking for. Okay, so that's what we're looking for. In order for us to have a minimum or the least, right, we got to have all this going on. Okay, so let's just look at these pictures that we have. Okay, from A to B. If I do the average rate of change between A and B, what's the slope between those 2 points? It's 0. Okay, the rate of change is equal to 0, so it can't be that one. Okay. Rate of change is 0. All right. So now let's look at the slope between B and C. Okay, what's true about your slope? It's positive. Okay, the slope is positive. That line is positive, so my average rate of change is positive. Okay, think about your radius. Is it increasing or decreasing? If I look at these points along it, is my radius getting bigger or smaller? Bigger. Okay, so R is increasing. That's not what I'm looking for. I need them to be opposites. Okay. Okay, let's go from C to D. What's true about your rate of change? It's 0. That ain't it either. Okay, it must be that last one. Let's make sure. Okay. So from A to D, what's true about your slope? It's negative. Okay, so the slope is negative. We're just looking if the slope is positive or negative. Now look at your radius. In other words, is the polar graph getting bigger or smaller? It's getting bigger. So it's increasing. So I have opposite descriptors, all right, a negative rate of change and an increasing, no, sorry. I said that backwards because I'm going from D to A. I'm going backwards. So it's decreasing. Okay, so I have the same descriptor because I wanted it to show me, right, negative and decreasing. Yep. So that's what we get. All right, it'd be that last one. Okay. All right, last thing. Estimating values of a function, all right? Sometimes we're going to get crazy values that we want to plug in, all right, to a function and we want to evaluate. We can do this. It's kind of like using point slope form. Of a line, so remember that's y equals slope times x minus x1 plus y1. So it's like using that, but we're going to put it in polar form. Okay. But it will be linear. We would set approximate f of theta is equal to my average rate of change. So we would have to calculate that. Theta minus theta sub 1 plus f at theta sub 1, all right, or my y value, all right? Average rate of change would be my slope. So we take the x's out and we put the thetas in, but it's the same thing. Last one, best one. Last new thing I have to show you. Woo! Okay. All right, so the table above gives values of the polar function at selected values of theta. Use the average rate of change over the interval from pi over 6 to 7 pi over 6 to approximate f at 5 pi over 6. Okay, so we don't actually have a function to plug it into. So this is where using that like point slope form of a line helps me. So the first thing I need is the average rate of change. So let's do that first. Okay, average rate of change would be f at 7 pi over 6 minus f at pi over 6 over 7 pi over 6 minus pi over 6. All right, so we got to get that. That average rate of change is the same thing as my slope that we're going to use. Okay, so f at 7 pi over 6 comes out of my table. It's -1. F at pi over 6 is 2. And then what would 7 pi over 6 minus pi over 6 give me? Give me 6 pi over 6, which would just be what? Pi. Okay, so my slope is going to be -3 over pi. Okay, so we can approximate f of theta to equal -3 over pi, theta minus, it does not matter which ordered pair you choose, so I'm just going to take that first one, pi over 6, and then I keep that f of theta value. Right, so that's my approximation for f. All right, we don't really know what it is, but that's the best I can do. Okay, is to write some form of a linear equation. So now it says to approximate f at 5 pi over 6. So here's what we're going to do. F at 5 pi over 6, we're going to plug it into that equation we just wrote. -3 over pi times 5 pi over 6 minus pi over 6 plus 2. That looks terrible, but do not panic. Okay. What is 5 pi over 6 minus 1 pi over 6? 2 pi over 3. You could even leave it 4 pi over 6. It will all work itself out in the end. All right. And then plus 2. right? When I multiply those two fractions together, first of all, what's going to happen to the pi's? They're going to cancel out, and I get negative 12 over 6 plus 2. Well, what's negative 12 over 6? Negative 2 plus 2. So what's that approximation? It's just 0. Okay, it is point slope form of a line. That's all it is. It's hidden with all that crazy polar looking mess, but it's just point slope. Okay. All right, so lesson practice comes from that very last worksheet I gave you. It's just 1 through 7. Okay, we're going to take a TV timeout break, all right, since this ends until 10 o'clock. Okay, so that gives you time to work on this. If you need a snack, get a snack. If we need to go tinkle, I'm going to open the doors so you can go tinkle. But we'll take a break, and then we're going to come back, and we will talk about our first set of review. Okay.